Hello everyone, and welcome to the 22nd video in the TypeScript Game Engine tutorial series. So in this video we're going to actually kick off our game development and we're actually going to fix a couple of long-standing bugs. Now, for those of you that have been following this series, you might have noted that it's been a little bit since I uploaded a video, and part of the reason for that is I wanted to sort of go through the engine and identify things that might need fixing and take some time to clean some things up and make sure that we have a really good foundation for making our game going forward. So the first part of this video, I want to focus on a few bug fixes that I've noticed and that other people have noticed. A couple of things such as the game doesn't run in some of the other browsers. There are some weird issues with loading with these animated sprites. So if you just refresh this page, you sometimes get this the entire sprite sheet here, whereas sometimes you don't. So I want to clean up some of those things and fix some of those things before we actually start developing our game. So let's go ahead and jump into that. So in a previous video in the behavior manager, this error was actually moved from a different location in the code, and the same problem is actually going to be true with the component manager. So right now this isn't actually going to do anything. So what we need to say here is we need to move this to be inside this block and say if the JSON type is not equal undefined, and if we get here and we haven't actually found a registered builder that works with this, then we go ahead and throw the error at that point. Because if the type is defined and we don't have some sort of builder here to handle it, we're actually not going to wind up returning anything. So I just wanted to fix that. Okay, so the next issue is actually in core GL. Some of the core GL code. So if I open up GLTS and I look here in this initialize, Internet Explorer doesn't actually use WebGL as the context. It actually needs something called experimental WebGL, and that's because it's old and not really updated, but it still supports it, and because there are some people out there that for some reason still use it, this is the one thing that I'm going to go ahead and fix for that. So one thing we need to check is if GL is also equal to null. So in other words, if it's undefined or null, then we want to handle this a little bit differently. And the reason I'm adding null here is because Internet Explorer actually, it was either Internet Explorer or Edge actually returns a null if this initialization fails, which is really strange. I would think it would return undefined, but anyway. So we actually want to try one more thing before erroring out, and that is to try loading the experimental WebGL context. So I'm going to copy this line here and just change this to experimental -WebGL. And I'm actually going to copy this entire block one more time and replace this throw error with the entire block and remove that. So at this point, what we have here is we try to get the context with WebGL. If that's undefined or null, then we try it with experimental WebGL. If that's still undefined or null, then we throw our error. So it's just a little bit of extra error catching to help support some of the other browsers. Okay. The next thing is in the shader, and I actually ran into this issue in Edge. So when you're looking at these info logs, I'm basically checking to see if this is an empty string, and for some reason Edge seems to return a non-empty string. There's some sort of white space in there or something, even though there's no error. And that's actually really strange to me, but the quick and simple fix to that is to add a .trim to the end of this get shader info log so that I'll trim any white space off the string in order to actually make it an empty string if there's nothing actually there. So I actually need to do that here and here when we're getting the program info log. And that should fix it on Edge. So again, just another small adjustment, but a needed adjustment nonetheless. And finally, the one that I want to tackle next is the animated sprite. So occasionally when you run the game, if you refresh and this is loading from cache, there's actually a race condition that's happening. And some parameters are actually not being set that need to be set in order for this to work properly. So we're going to go ahead and fix that now. So the first thing that I need to do is go all the way to the bottom of the file, and we're going to create a new method right after calculate UVs. So it's going to be a private, and we're going to say setup from material. It's going to be return type void. And we're going to check if this dot asset loaded, if not this dot asset loaded, sorry. And what we're going to do is we're going to check first the material. So let's get the material. So we'll say let material equal material manager dot get material, and we're going to say this dot material name. And the next thing that we're going to say is we're going to check to see if the material diffuse texture is loaded. And if it is loaded, then we're going to go ahead and set some things. But one more thing that we need to check is we need to say if asset manager dot is asset loaded material dot diffuse texture name. Okay, so it might seem a little bit strange to check and see if the material is loaded, if the material's diffuse texture is loaded, and also check to see if the asset's loaded. But the reason that we're doing that is because these are two different things. So if you recall, when we actually set up our textures, we put some temporary data into that texture right away so that it's immediately referenceable. So technically there are cases where this could be true, but the actual asset that it relies on is not yet loaded. So we need to check both those things. So if we get to this point, that means that everything is loaded as it should be, and we need to actually set some stuff up. So we need to say this dot asset height equals material dot diffuse texture dot height. Okay, and I'm just going to copy this line because we're also going to do the same thing for width. Okay, and we're going to set this dot asset loaded to true, and then we're going to call this dot calculate UVs. And that's just so that this logic gets run at the correct time if we happen to run into a race condition such as the texture already being cached. Okay, so there's a couple of other places that we're going to have to now call this method. The first of those being in load. So after super.load, we want to say if not this dot asset loaded. And we're going to say this dot setup for material. So basically we're going to say if we are at the point of loading and we do not have the asset loaded at this point, go ahead and set up the material, or at least attempt to. Okay, and in the update, we also have a check to see here if the asset's loaded, and if it's not, we return. But before we return, we want to basically use this same exact code here. So I'm actually just going to copy and paste this. Right, so basically, while our asset's not loaded, we're going to continually check to see if the asset is loaded, and if it is, then we'll go ahead and set it up. And then we'll return, and then we'll go ahead and perform the update on the next cycle. Now, there's a couple things wrong with this. This isn't the optimal way to do it. Really, this stuff should be happening probably in another step that we need to add, such as like a update ready or preload type of step, or pre-update type of step. But at least for now, this will actually solve that bug. So if I go ahead and build this and run it, now we'll see, no matter how many times I refresh, it's fixed. So we are still getting this this weirdness on the first frame here, but I'm not really too worried about that right now because some changes that we make later on are actually going to wind up fixing that. So for now, this issue is fixed. Great. Okay, so the next thing that we're going to wind up doing is we actually need to add a few things in into the engine to make things behave a little bit differently. So one thing that we need to do is right now, when we run the game, it's taking up the entire screen, and that's actually not going to be optimal for the type of game that we want to create. We want to have a fixed size because we have a sort of fixed per pixel sort of resolution that we're going to need for this type of game to sort of emulate the old school look. So there's a few adjustments that we need to do. Okay, so the first thing is in our engine class. There are a couple things that we need to add. We need a private game width, which is a type number. We're just going to leave the default to undefined. And private game height, which is a number. And in the constructor, we are going to take in an optional width number and optional height number. Okay, and I'm just going to add some comments here. RAM width, the width of the game in pixels. And I'm actually just going to copy this line and say height of the game in pixels. Okay, and then simply just set this dot game width equals width, this dot game height equals height. Alright, and then under the start method, before we actually initialize anything else, but right after we initialize OpenGL, we want to say if this dot game width is not equal to undefined, and this dot game height is not equal to undefined. Then we're going to say we're actually going to set the width of the canvas as well as the CSS width of the canvas. Let's see, what did I mess up here? Oh, I forgot to say undefined. There we go. Okay. So this canvas style dot width equals this dot game width plus px, because it's a CSS style, we actually have to add the pixel in there. And I'm just going to copy that line and change this to height and change that to game height. And then I'm going to say this dot canvas dot width equals this dot width, game width rather. And again, I'm just going to copy that, paste it, and change it to height and game height. Alright, the next thing I want to do is I'm going to remove this debug code out of here. The mouse up subscription message, that needs to go. That was only temporary test code, so I want to go ahead and get rid of that. And I'm going to go ahead and change actually the background clear color while I'm in here, because I'm going to need a different color. This is going to match up to something later on. So just take these values, just take these at face value for now. So it's going to be 146 divided by 255. 206 divided by 255, and 247 divided by 255. And the reason I'm dividing those by 255 is to get that 0 to 1 number. So these are RGB colors. So if I were to load these up in an image editor, you would see 146, 206, 247, which is sort of a light blue. Okay, so another thing I'm going to do real quick is I'm going to change up this material here, this crate, because this is just a sort of test material and I want to get rid of that and actually replace it with something we're going to use. So I'm going to call this grass and change this to grass PNG. And if I look at the textures, I actually have the grass in here, so we don't need the crate. I'm going to delete that. These assets can actually be pulled off the GitHub repository. So as I go through these lessons, I'll be adding the assets up there as well. Okay, the next thing that I need to do is go ahead and add a couple more sounds because we're going to need these. So I'm just going to copy this line, and I'm going to change this to ting, and I'm going to change this one to, I'll call it dead. Dead. Change the file names accordingly. So those are just different sound effects that we're going to need. Alright, and cool. So as far as the width and height stuff goes, now I'm going to come in here to resize, and I'm actually going to change this up a bit to function the way that we want it to. So I'm going to say if this.game width is equal to undefined, or this.game game height equals undefined, then I'm going to run that logic. And so what that's going to do is basically if I don't define these things, then it's going to default to a sort of full screen behavior. Otherwise, it's not going to set these, and it's just going to stay at the size that I tell it to stay. Okay, and one last minor thing is in this on message in Engine, I've got this this mouse up where I'm playing a flap sound. I want to get rid of that because we're actually going to be doing that elsewhere. So that's actually going to wind up being hooked up properly. Okay, so just for a sanity check here, let's go ahead and build and run. And we'll refresh. And I forgot a couple of things. So one more thing I need to change is I need to actually come in here to the test zone JSON, and I still have a reference to my crate material name here. This actually needs to be changed to grass. And I believe that's actually it. I actually don't want 0.5 origins on that, so I'm going to remove that. And I'm going to leave these as is for now. I'm going to be renaming those things and reconfiguring them in a bit, but I think that should be good. Actually, while I'm in here, on the duck, I'm going to change his scale to 2 and 2, because 8 by 8 is a little large. And yeah, I'll come back and do the rest later. So let me just rebuild again. Okay. Alright, so as you might notice, our grass kind of looks a little bit messed up, so we need to fix that, but at least our duck is in here. He kind of looks like a decent size. But you'll notice that we're actually still in full screen behavior because there's one thing that I didn't do. And that is, in app.ts, I'm actually not passing the width and height in so that we know what our window size should be. So in this case, it's going to be something really low. It's going to be 320. by 480. I think that's what we can stick with for right now. One other thing is I want to open up this index.html and remove this style rule for canvas altogether. We don't need it anymore. Okay, and now let's build and run. Great. So now our canvas is the size that we expect it to. And in case you haven't guessed yet, the reason for this is actually going to be so that this fits onto mobile phones a little bit better. So I just sort of ballparked this resolution. We'll actually make this this page capable of sort of centering itself and whatnot later on using some CSS, but that's not really too important right now, so I'm going to kind of I'm going to gloss over that for right now and just focus on the more important stuff. Anyway, let's close that. Okay, so there's a couple more adjustments that we need to make before we move on, and a couple of things that I want to add just for utility and things that are going to help us out a little bit further on down the road. So the first is we need to add a couple of math utilities. And I'm actually going to call this file math extensions. And what we're going to do is we're going to actually extend the math object a little bit. And the reason we want to do this is because we want a nice, easy way to access a couple utility functions that we're going to be needing to use quite often. So first thing I'm going to do is put in interface math, and we're going to add clamp, which is going to take in a value, which is a number. It's going to take in a min, which is a number, and a max, which is a number. And it's going to return a number. This is a pretty standard function in a lot of libraries, but for some reason they didn't choose to include this in when they were defining JavaScript, so we have to add it. The next one is going to be, we're going to call this deg to rad, which is degrees to radians. This is also going to be another extremely common function that we're going to need. It's going to take in degrees, which is a number, and return a number. And we also want rad to deg, which is radians to degrees. And we're just going to take in, as you may have guessed, radians, which is a number. It's going to return a number. Okay? But all this does is just adds it to an interface that we can access in TypeScript. This doesn't actually define anything. And so the way that we're actually going to add this is it's sort of going to use a little bit of a TypeScript hack, but it's going to make it nice and easy for us to use on the surface. So I'm not usually a fan of having to do hacks, but because of the way that a lot of JavaScript stuff is sort of done, every once in a while you have to do things like this. So we're going to cast the JavaScript math object as an any, which will allow us to append a clamp property to it, which is going to be a function with the same signature that we have up here. Okay? Whoops. Need a fat arrow there. Okay, so what this is basically saying is we are adding a function to the math library called clamp, and its value is, or its definition is here. Let's see. Oh, okay. It wants a return value. Okay. So we're going to say if value is less than min, we're actually going to return min. If value is greater than max, we're going to return max. Otherwise, we're just going to return value. Short and sweet. Okay, so the next one that we need is we need to say math as any again, and we're going to say deg to rad. Okay, and degrees, number, return type number, And the algorithm for this is pretty simple. So we're going to say return degrees. Whoops, I messed this up here. That should be an equals there. Okay, so we're going to say return degrees times math.pi divided by 180.0. Okay? And the next function is actually going to be pretty similar, so I'm actually just going to copy and paste it and change it to deg to rad, change this to radians. And the only difference between this function and the last one is the order of these last two numbers. So instead of math pi divided by 180, it's 180 divided by math pi. And that's it. So those are just a couple of quick extensions that we've added to the math interface in order to allow us to quickly access these functions. Alright, enough of that. So, the other thing we need to do is we need to extend the vector2 class a little bit. And so, right above set from JSON, we're going to add another public method, and it's going to be called toVector3. And it's going to return type vector3. This function's use will make itself evident later, but I want to go ahead and get it out of the way now. So return new vector3, and this pass this dot underscore x, this dot underscore y, and then the z is going to be 0. Again, nice and simple. The other thing that this one has that this one doesn't have, rather, that vector3 does have, is vector3 has this set method. And for some reason we didn't add it to vector2, so I just want to paste a copy of that in here and remove the stuff for the z-axis. So it gives us a nice convenient way to set both x and y at the same time. Okay, and right above clone we also want to add one more thing. We're going to call this public scale, and we're going to take in scale, which is a number, and we're going to return a vector2. Whoops, vector2. Okay, and we're going to say this dot underscore x times equals scale, and we're going to do the same thing for y. And this just gives us a quick way to scale this particular vector without having to do this sort of manually outside the context of this. So we're just going to return this, we're going to modify it and then just return this. Alright, that is it for vector2. The next thing that we're going to need is an additional step between our load and update for our components, our sim objects, and technically behaviors should also have this step. And what that's going to be called is update ready. And so what update ready is it's basically saying, okay, we've loaded everything up to this point. Before we run the first update, call this method, and then start running update. And the reason that we need this is because if we do certain things during load, you may have a particular race condition where something may not be loaded up yet because you haven't gotten to that part in the actual zone configuration yet. So we want to actually wait until the loading is complete and then have a separate step that says, okay, update is ready. Let's call that, and then anything that needs to actually perform that action can go ahead and do it. So this is more of an interface update, but we are actually going to need this for our game, so I wanted to go ahead and get it in sooner rather than later. So the first thing we need to do is an iBehavior before update. We want to say update ready, return type void. Okay, and I want to go into iComponent and put it in the same place. And then if we go to base behavior, in the same place in the actual implementation, we want to just add update ready to that. And it doesn't actually do anything, but it gives us the ability to do something here if we want to in this step. Okay? And the same thing is going to be true in base component. So I'm just going to copy that over here. Right before update, put that. And let's just clean this up a little bit here. Okay. Alright, so the next place we're going to have to do this is, as I mentioned, is in the sim object. So if we look at update right before that, we're just going to put this in here. And I'm actually just going to copy these 3 loops from update, paste them here, and I'm going to remove time from all these and change these to update ready. Okay? So basically it's going to call it for components, behaviors, and then recursively call it on children. And that is actually most of the interface level changes for that. Now we actually need to call it from somewhere. And so this is actually a quick one-liner. If we go into zone TS and we look at the load, right after load is complete, we could just say this.scene scene.root.update ready. And that will just recursively call it down the tree. So now that's being done, we don't have to worry about it anymore. So I want to sort of flip back to SimObject for a moment, because there's a couple of things that I want to add for some nice utility in this object as well. And so right here we have the ability to get an object by name, and this recursively searches down by children, but we don't have that same ability for components and behaviors. So I think this would be a nice thing to go ahead and add. So the first thing we want to do is add a public. Let's see, do we want to do this? Let's actually do it. Let's do it above this. So we'll add a public get component by name. Name is type string, and it returns an I component. Whoops. I component. Okay. And say for let component of this components if component dot name equals name, return component. Right. And then if we get down to this section, we're going to say this or for rather let child of this dot children. So we want to recursively search the children. And then we'll say let component equal child dot get component by name. We'll pass name through. So this is just calling this same exact method on the child. And then we say if component is not equal to undefined, return component. And all the way here at the bottom, we would want to just say return undefined. So if we don't find it, we want to just return undefined. And the nice part about this is it works the exact same way for behaviors. So we could just copy it, change this to behavior, I behavior, rename this to behavior for clarity. This dot behaviors, right? And then we'll rename this one as well. Change this to get behavior by name, and that should be it. So just a couple of nice, quick utility methods, so that if we, for some reason, we want to get an object or get a reference to a component that's attached to an object by the name, now we can do that very easily. So the next thing that we want to do is we actually want to go back to our animated sprite, which is in graphics. And we want to make a couple of small changes to this. So right now, this sprite just plays all the time, and there's no way to stop or pause that animation at any time. It's always just going to be playing no matter what we do. And so I want to add a new property, private property here. We're going to call it isPlaying of type Boolean. We're going to default it to true, right? So that's the same behavior that we have right now, but this will allow us to sort of toggle that on and off. Below the constructor, we'll have a public get isPlaying. Return type Boolean, and it's just going to return this.isPlaying. Make sure you have the underscore version of that there. Just add a quick comment. Indicates if this animated sprite is currently playing. Okay. So the next thing we want to do is, I'm going to say, let's go ahead and make this towards the top because these are going to be commonly called methods. We want to add a new public method, and we're going to call this play. Return type void. And we're just going to simply set this.isPlaying to true. And I'm going to copy this method, paste it, rename it to stop. And as you may have guessed, changes playing to false. The next thing is we want another public method called setFrame. And we'll call this frame number, type number, return type void. So this is going to give us the ability to set a specific frame of the animation. So if we want to start at a specific point or we want to stop and set the animation to a specific frame, this is how we do it. So we'll say, first off, let's do a sanity check. We'll say if frame number is greater than or equal to this.frame count. Then we want to throw a new error, and we'll say frame is out of range. We'll say plus frame number, and we'll say frame, comma, frame count, plus this.frame count. Alright, so if we pass that test, then we'll say this.current frame equals frame number. Nice and simple. And to hook this all up, it literally becomes as simple as after this asset loaded check, but before we run any of these other checks, we're simply going to say if not this.playing, this.isPlaying rather, return. So just boot out early. It's as simple as that. So now we have the ability to stop and play our animations at any given time very simply through a couple of method calls. And so the next thing we probably ought to do is expose these to the animated sprite component. And so if we actually look at the component itself, we want to add something first to the data. I'm going to say public, and we're going to call this autoplay, type Boolean, and it's going to default to true. So what this is going to say is if autoplay is on, it's going to go ahead and play the animation straight off the bat, which is the default behavior. Otherwise, if it's false, you're going to have to call play in order for that to actually start playing. Okay, and I'm just going to copy one of these methods here. I'm going to copy this one. Just put it above, and I'm going to delete this and say if json.autoplay is not equal to undefined, then this.autoplay equals cast to Boolean json.autoplay. So now we can configure that as well. One more thing, there was another bug that I found here having to do with the origin. So if we look at our Sprite component real quickly, we have this code here that is setting the origin if the origin is not default. So we actually just need to paste a copy of that code in here, because what we're doing is we're calling super, which does technically run this code, but then we're overriding Sprite with an animated sprite, which wipes that out. So we just need to add that code there to fix that bug. Right here, below the constructor, we need to expose is playing, which is a boolean, and we're just going to return this .sprite .is playing. Okay, and in load, before we move on, let's actually also save off autoplay. Save that. Actually, I don't need a default there. We'll just copy it from the data. We'll say this.autoplay equals data.autoplay. Okay, and in load, actually, this is a prime candidate for our update ready. So we'll say public update ready. If not this.autoload, or autoplay rather, this.sprite.stop. So we'll immediately call stop on that, just so it doesn't actually start playing right away. Okay, so the next thing we're going to need to do is expose just the play, stop, and set frame properties. So I'm actually going to go back to animated sprite, and I'm actually just going to copy them real quick, just so I don't have to retype all those function definitions. And below render, I'm going to paste. And in this .play, I'm going to say this .sprite.play, and stop. I'll say this sprite stop. And in set frame, I'm going to say this.sprite.setFrame frame number. Nice and simple. Again, it's just a pass through, but it's a nice, quick, convenient way for us to actually set up, or to be able to stop and play animations, as well as configure autoplay. Okay, so I know we're sort of jumping around a bit, but I'm really just trying to get a lot of things situated before we actually jump into our full development here of the game, because this will be a lot less back and forth if I do all these things now. So the next thing is in Sprite Component, we actually need a way to dictate what the width and height should be. So we need public width number, public height number. And I'm actually just going to copy this here, paste it, and say if JSON width is not equal undefined, this width has to a number is JSON width. And I'm just going to copy this whole thing and place width with height. Okay, and I'm just going to copy these guys and change them over to private. And copy them them over from the data. So width equals data.width. This.height equals data.height. And then in the sprite, you'll notice in the constructor, it actually takes, beyond material name, it takes width and height, and we just weren't passing it in. So now these things are going to be configurable. So we can just pass this.width and this.height in there. We're going to need that later on, so I wanted to go ahead and get that in there now. Okay. So the next minor thing is we're going to be doing some stuff with the collision manager, and so I need to hook up support for a couple things here to notify things outside of the collision manager that a collision has happened. So the first thing I need to do is export this top class, because I am going to wind up using it outside of this. And then in our update, where we're creating a new collision and we're notifying those two collisions of each other, before the push, we need to send out two messages. So we need to say message.send. Whoops. We need to send that priority. We need to actually send it immediately. And we're going to say collision entry and then colon plus comp.name. And then the sender is going to be this, and the context is going to be the collision data that's created here. And I'm going to copy that and change it to other.name. So basically the code is going to say this, we have a collision entry for this object and a collision entry for this object. And so that way, if we have anything that's listening for that out there, listening for that collision, it can react to it immediately. Okay, and I'm actually going to copy these two lines, and I'm going to do the same thing for exit. So after both of those objects have been notified, I'm just going to change this to collision exit and change comp to data.a and other to data.b, and then change call to data. Right, so it's basically going to be doing the same thing, it's just on the actual exit. And I've got this to do remove me in here. This was just a quick test to make sure our collision stuff is working. This can definitely be removed at this point, so I'm going to go ahead and get rid of that. And that's it for that. Again, just a pretty simple, straightforward change. Okay. So after that, we are finally ready to go ahead and start creating our gameplay. However, I think this video has gone on for quite a bit, so I think I'm going to split this off into another video. So stay tuned for that. Thank you guys so much for watching. I hope you enjoyed this. I hope you learned from it, and I will see you guys next time.